Hello friends, in this video we will do the derivation of the mirror formula for convex mirror. Here XP dash is a convex mirror where PF is its focal length and PC is the radius of curvature. AB is the object which is kept at a distance u from the pole of the mirror. Now let's begin. Now in order to derive the mirror formula, what we will do is the very first thing which we need to do over here is we trace the position of the image. Say for that from point A, if I draw a ray parallel to the principal axis, then after reflection, the reflected ray will appear to be coming out from the focus. So this is the direction of the reflected ray. So here we say that this AN is the incident ray and the reflected ray is going in this direction. Now from point C, if I connect N and if I extend this ray further, this line further, then what I get over here is this angle as angle of incidence and this angle as angle of reflection. Similarly, if I extend this reflected ray backward, then this ray obviously will meet at F. I hope this figure is clear to all of you. Okay, now here we have only drawn one ray. Now in order to basically trace the location of image, we require minimum 2 rays. So another ray which we will trace over here is from point A. Say if the ray is projected towards the center of curvature, then this light ray will retrace its path back. Means if any ray which is directed towards the center of curvature of the convex mirror, after reflection it retraces its path back. Now as we can see the two reflected rays, okay, that is this ray says from meets at point M. So as we see, these two reflected rays are diverging away. They are going away from each other, so obviously we are not going to get a real image. But if I see the extension of these two reflected rays, they are meeting at this point. So what we consider over here is, we consider the image which is a virtual image getting formed over here. Now this A dash B dash is the virtual image of the object AB. Okay. Now apart from these two standard rays which we have drawn, we will draw one more ray from point A. Say the ray is directed towards the P and obviously this ray will undergo reflection. Now when I extend this reflected ray backward, then this reflected ray will also meet at point A. Okay, so our ray diagram over here is ready. Now from this ray diagram, what you need to do is you have to identify two sets of similar triangle. So the first set which we can see over here is triangle ABC and triangle A dash B dash C. If you see, triangle ABC is similar to triangle A dash B dash C. See how it is similar? Angle ABP 90, angle A dash B dash C is also 90. This angle C, that is A dash CB dash and ACB, both these angles are common. So obviously the third angle would also be equal. So ABC and A dash B dash C are similar triangles. Now from this, I can write a relation that A dash B dash upon AB, that is the ratio of the perpendiculars of these two triangles, equals to B dash C and BC equals to B dash C and BC. Okay, now B dash C can be further written as PC minus PB dash, and BC, this entire line, this can be written as PB plus PC. BC is nothing but this PB plus PC. Okay, so let this be equation number 1. Now we see the other set of a similar triangle. The other set of similar triangle is triangle ABP and triangle A dash B dash P. ABP, A dash B dash P. Okay, now why this is similar? ABP, A dash B dash P, these are 90 degree. Now this angle is I, this angle is R. Obviously these two angles will be equal, and this angle which you see is the vertically opposite angle. So obviously I and this angle would also be same. Okay, so the value of this angle is I, then value of this angle will also be I. Although this is not an angle of incidence, but since the values are same, that's why I'm writing I and I. Now we have this two sets. We have the set of similar triangle ABP and A dash B dash P. Now again, what we can do is we can write the ratios of the two sides. That is A dash B dash upon AB. This will be equal to PB dash upon PB. A dash B dash upon AB equals to PB dash upon PB. Now say this is equation number 2. Now if we see these two equations, we can directly equate them. Now equating equations 1 and equation 2. Now if I equate these two equations, I can write over here PB dash upon PB equals to PC minus PB dash upon PB plus PC. Okay. Now after this, what I need to do over here is, or what we need to do over here is, we have to replace all this PB, PB dash and PC with U, V and R. Now this PB dash is obviously the image, so this we can write it as V. Now see over here, PB is U, PB dash image distance V, PF is obviously F and PC is R. But remember, when we replace this PB, PB dash PC with U, V and R, then we have to do it along with the sign convention. Now first let's understand what would be the signs of all these terms. Now U will be negative. Why? Because if I have to measure U, I have to measure it from the P, and since in order to measure this distance PB, we have to move opposite to the incident ray direction. So the incident ray is going from left towards right, and in order to measure PB, we have to move from right towards left. So U will be negative. Okay, so here I can write PB, this will be minus U. Now what about PB dash? PB dash will be positive V, because if I have to measure PB dash, that is V, I have to move from left to right, which is the direction of the incident ray. Incident ray is also going from left towards right. So PB dash will be plus V. Similarly, PF will be plus F and PC will be plus R. So when I replace the PB dash, PB and the PC with these terms, what I get over here is, now PB dash will be plus V PV will be minus U. This will be equal to PC. PC is plus R, PB dash plus V, PB again, PB is minus U, and PC again is plus R. Okay, now let's do a simplification. Let's do the cross multiplication. Now when I do the cross multiplication, what I get over here is minus UV plus VR equals to minus UR plus UV. Okay, now let's take all the R terms on the one side and UV on the other side. So if I bring this R term over here, I get VR plus UR equals to, when the UV goes on the other side, this becomes 2UV. Or I can write R equals to 2UV upon U plus V, or R by 2 equals to UV upon U plus V. Now when I take the reciprocal of this becomes 2 upon R equals to U plus V upon UV, or 1 upon V plus 1 upon U. Now we already know beforehand that R is nothing but 2f. This is the relation between the radius of curvature and the focal length. So obviously R by 2 will be what? 1 upon R by 2 will be f, or 2 upon R we can write it as 1 upon f. So this expression becomes, I can write, since R equals 2 by f, then the above expression becomes 1 upon f equals to 1 upon V plus 1 upon U, which is nothing but the mirror formula. So this is the mirror formula, and we did the derivation for the convex mirror.